Do you want to make a multiplayer game but have no clue how to even get started? Well then you clicked on the perfect video, since in this video I will show you how to go from an empty project to a cute chatroom game with players that can move around and send text to each other. Also, if this tutorial ends up helping you, consider thanking me by liking the video and subscribing. Also go wishlist my game on Steam. That's enough self-promo, let's get started. We will start by importing some packages. If you head to the multiplayer center, we will be able to get everything at once. What we select here doesn't matter since we will configure this manually. Make sure the netcode solution is on 4 game objects, have multiplayer tools ticked, set the hosting model to client hosted, and make sure you have services and play mode ticked as well. Now you just need to click install packages and wait a bit. Once it's all installed, we will start with the menu. Simply set up an empty object with a camera and a canvas under it. Then under the canvas add 2 buttons, one for hosting and one for connecting. Next, make a script that will handle our lobby/menu. Let's import unity.net code, then make a public method that will host our game. In this method, call the start host function on the network manager singleton, then destroy the lobby object. Duplicate this method and change its name to join, and change the network manager call to start client. Back in Unity, add an empty game object called network manager, then add the network manager component to it. Click on select transport and choose Unity transport. Next, select your lobby and add the lobby manager script we made to it. Then, assign your buttons to call the host and the join functions. If you run the game now and click host, you will see that the lobby gets destroyed and the game freezes. That's because we don't have a player that the network manager can spawn. So, let's make it. Add in a queue that will serve as the ground, then add a capsule for the player. On the player, add the network object component and the client network transform component. On the transform, change the authority mode to owner. It's important to know what these components do. The network object makes sure that this object is synced, and it also allows clients to own an object. The client network transform allows each client to automatically sync its position, rotation, and scale to every other client. And the network animator syncs the state an animator is in, allowing you to easily sync up animations. If at any point you have an issue with one of these, double check that the authority is set to owner, otherwise only the hosting client will be able to use them. Back to the player now. I'll turn mine since I want a 45-degree view. Next, add a camera under it and position it. Make a folder called resources and drag the player into it. It's important that it's called resources, otherwise the network manager won't accept it. Next, drag the player prefab into the default player prefab slot on the network manager. If you try hosting a game now, a player should appear. But a static player is no fun, so let's add in some movement. Make a script called player movement and open it. Import unity.net code and unityengine.networking. Then, make the script extend network behavior instead of mono behavior. Next, create 2 exposed variables, a game object for the camera and a float for the movement speed. In the start method, check if we are the owners of the network object, and if we aren't, then disable the camera. Since this video isn't about movement, I will be making some extremely simple movement using the old input system, but you can make it however you want. In the update method, check if we are the owners, and if we are, let's store our input. Next, let's normalize this input to make it consistent, and add it onto the position, multiplied by the speed and data time. Since my player is rotated, I will add it in 2 separate ways to make it align with the transforms forward and right vectors. If at any point you want to execute a function only on the owner's client, you just use isOwner. And remember that isOwner is under the network behavior, so make sure your script extends it. Back in Unity, drag the script onto the player, drag in the camera, and set the speed. If you test the game now, we will see that the player moves as intended. And if you use the multiplayer test mode that you can enable at the top of the screen, we will see that the movement correctly syncs between clients. Now that we have our players added, let's add the chat functionality, which means it's time for the most versatile part of networking, the remote procedure call, or you can just call it RPC for short. RPCs allow us to call functions on other clients or on the host, and we will be using this to send the messages. Let's set up a workspace canvas for the messages since we want them to be above the heads of the players. Next, add an empty object, stretch it vertically, then add a vertical layout group to it. Next, let's add an empty game object which will be our message. Under it, add a background image and a text. Let's save this as a prefab, and now let's make a new script for the chat message. This one is very straightforward, just import tmpro and make a variable for the text. Then, make a function to set the message up by taking in a string and setting the text to it. Lastly, destroy the entire message with a few second delay. Back in Unity, add the message component to the object and assign the text. Also, don't forget to delete the one inside the player if you haven't deleted it already. Next, let's make our chat manager script. Import netcode, networking, tmpro, and make the script extend network behavior. Next, let's make some exposed variables for the message input field, the message panel, the chat message prefab, the message send window, and the player movement script. Then, in our update method, check if we are the owners, and if we are, let's call a function to start sending a message when we press the enter key. In this function, let's enable the message window and then let's disable the player movement. Next, make a function to send the message, and then make two other functions that will serve as the server and client RPCs for sending and displaying the message. When you're declaring an RPC, you must use the appropriate attribute for it, and you must also include the type in the name of the function as well. Also, it's important to know what each of these RPC types do. Server RPCs call their function on the same game object, only on the host's client. You must be the owner of the object to call it, but that can be bypassed by setting require ownership to false. Client RPCs can only be called by the hosting client. They will call the same function on every client, including the hosts. You can pass an infinite number of variables with RPCs, but they must either be built-in C# types, basic Unity math types, or structs that only contain the things previously mentioned. Back to our code now. Make the server RPC call the client RPC and pass in the message. Then, make the send message function call the server RPC and pass in the text from the input field. Then, reset it, disable the message window, and re-enable the player movement. Then, in our client RPC, instantiate the message object, parent it to the panel, and reset its local position, rotation, and scale. Next, get the chat message component from the message object and set it up with the message that the RPC got passed. And with that, we're basically done, so let's step back into the editor. Add the chat manager to our player, and then make a new canvas for the message window. Create an empty game object under the canvas, and add an input field and a button under it. On the button, make the onClick call the send message function in our chat manager. Then you just need to assign all the variables in the chat manager. And lastly, disable the message send window. And with that, it's all working. If you send a message, both clients will display it. There is one small issue with this. While this works locally, if you want to play with others, the host would need to port forward, which is a lot of work. So let's fix that by adding Unity Relay. Relay lets us connect players to Unity's servers. Do keep in mind that Relay is a paid product, but Unity lets us use it for free for up to 50 players at once, so it's perfect for quickly testing multiplayer games. To get started, connect your project to Unity Cloud in the hub. Then in the Unity dashboard, select the project, click Services, find and click Relay, click Get Started, then skip through the steps since we already have it installed. Back in Unity, select the Network Manager object we made, and on the transport, change the protocol to Relay. Next, let's set up the input field for the lobby code. For context, Relay uses lobbyCode's nowhere to connect you. Open our Lobby Manager script again and import the following: unity.services.core, unity.services.authentication, unity.services.relay, unity.services.relay.models, unity.netcode.transports.utp, and tmpro. Next, create two exposed variables, one for the code input field and one for the text that will display the code for the host. Next, make an asynchronous start method where we will initialize the Unity services and sign into them without any user credentials. In our host method, let's set up the allocation. The number you pass here will be the size of your lobby. Next, set the text of our lobby text to the join code, and lastly, set the relay data on the Unity transport. In our join method, we're going to do a try catch in case we fail to connect. Make a join allocation and set it up by joining the allocation through relay. You should pass the text from the input field here. Next, set the relay data up for the transport. And lastly, if you have an issue, log the message as an error on the console and then return so we don't destroy the lobby or try to start the client by accident. Also, don't forget to mark both methods as async like I did. Back in Unity, add a canvas under our network manager and add an empty text that will be our code display. And lastly, assign both the text and the input field in our lobby component. And we're done. If we click the host, the code will be shown by our text, and if we input the code in a second client, it will connect like usual. I really hope this helped you out. If you end up making something cool using this tutorial, do share it in the comments. Also, there are still many more features of NGO that I haven't gone over here, so let me know if you want a part 2 of this tutorial. Also, if you want to see how netcode for game objects and relay perform in a real game, I have a free multiplayer shooter that uses them. And yeah, that's about it. Like, subscribe and all the usual stuff.